Good morning, and welcome to our webcast, Simplifying OpenEdge Data Access with DataDirect, presented by Progress. I'm your host, James Goodfellow, and I'm a Product Marketing Manager within the Data Connectivity and Integration Group here at Progress. Joining me today is my colleague, Ken Butler. Ken is a Product Manager here within Data Connectivity and Integration Group. Hey, Ken, how are you today?
Good morning, James. Happy to be here.
Thanks. Today, we're going to talk to you about a new product we've launched called Autonomous REST Connector and how OpenEdge partners and customers can use this product to vastly expand the ways that you share application data with your customers. Before we get started, I wanted to let you know what to expect on today's webinar. Ken and I are going to start off by walking through a couple of slides that describe our new product offering. Then Ken is going to give you a live tour of the product in action. Finally, we'll wrap it up with your questions. Let's just jump right in. Data access has certainly changed a lot over the past few decades. We've gone from connecting one machine to another, then to a network of data sources, and now, of course, we have a near limitless number of on-premises and cloud-based data sources we can access. App developers have traditionally had a limited sphere of systems to connect to, relational databases, data warehouses, etc. These were generally closed, controlled systems that didn't require extensive authentication or security measures. To meet this need, ISVs have traditionally built SQL connectors that are ODBC and JDBC driven in order to share application data with customers. SQL access to data has been a common and traditional approach for decades. Connecting enterprise BI, analytics, or data management applications generate a SQL request using ODBC or JDBC to a backing data store, or OpenEdge in this example, and the data is returned, updated, created, or deleted. There are a few common pitfalls, though, when needing to support this kind of model. First, each one of these applications has a set of users that are using more and newer data sources, REST APIs, cloud applications, operational databases, and so on. The list of sources that these users require grows every year, and it's hard to keep up both for us and for our customers. Second, given the breadth of users, it can be difficult to maintain so many point connections across so many data sources. Who's accessing the data and what they're doing with it can be a hard question to answer. And most importantly, standardizing how data is being accessed, such as retrieving the current list of customers that are active, is almost impossible. But you're probably asking, why not just use ODBC, JDBC drivers that Progress ships with OpenEdge today? Well, you could, but remember, they connect directly to the database, bypassing your application boundaries. You've probably heard the saying that data is the new oil, and that analogy makes a lot of sense when you think about the valuable insight and advantages that can be achieved by mining and analyzing data. But I think a better analogy is data is the new uranium. It can power a business or it can destroy a business. So you often need to protect against giving your users data access to your database. There are many reasons why this is the case. Perhaps you've implemented a multi-tenancy solution and direct access would expose all tenant information to everyone. It's not good. Perhaps you are facing some regulatory compliance requirements such as PCI or GDPR that requires you to treat personally identifiable information in an especially sensitive way and control who can access it. Or perhaps the database schema is overly complex and wouldn't be user-friendly to the person conducting the analytics. Or perhaps you want to prevent a rogue user from issuing a query that could infringe upon the quality of service for your other users and customers. There are several roadblocks that pop up between your OpenEdge application data and the customers who need to access that data. First, many of the BI and ETL tools that your customers are using don't necessarily support OpenEdge out of the box today. Often this puts the burden of connectivity on the customer, and that's really not good for your business either. Second, most of these same tools do support ODBC and JDBC as they're the most popular data access standards out on the market today. And third, while open standards are plug and play for most of the tools your customers will be using, they lack the data security and integrity measures necessary to adequately protect customer data. Think of all the data handling and privacy regulations that businesses face worldwide. One very popular way of addressing these data integrity concerns is by locking down the data sources and exposing it only via API. And recently, we've all seen the reign of SQL access is given way to REST APIs, and for good reasons. More and more demands are being made of the data sources, and it becomes prudent to ensure the security and integrity of the data and those that are accessing it. Within the OpenEdge world, we are fully aware of the benefits of using REST services versus traditional SQL. This chart does a great job, I think, of illustrating the massive shift that we've seen to APIs over the past decade or so. In fact, according to Programmable Web, who created this chart, there are almost 20,000 public APIs currently available. Additionally, enterprises are creating hundreds of thousands of private internal APIs and microservices. Many organizations are leveraging these APIs to create data services to effectively govern how data is accessed, where it is accessed, and by whom. While modernization efforts drive companies to produce and consume APIs, the applications and tools they leverage are still SQL-based, making it difficult and time-consuming to connect those REST and SQL-based tools. With all this in mind, we at Progress set out to create a product that would bridge the divide between convenient data access for your customers and secure data governance for OpenEdge developers, and that product is Autonomous REST Connector. Autonomous REST Connector is an intelligent, customizable data connectivity solution, enabling lightning-fast, codeless connections between your OpenEdge application data and your customers' preferred BI analytics and data warehousing tools. Autonomous REST Connector provides seamless connectivity and integration with REST APIs, OData endpoints, and Progress OpenEdge JSDO catalogs. There are 4 primary characteristics to this new product. 1, SQL access. The product allows you to query REST endpoints just like a standard database. 2, the ability to normalize the JSON results based on your specific relational schema. 3, intelligent sampling. And this is really the secret sauce, as it interprets metadata automatically and infers the correct relationships. And 4, authorization and authentication. Now you can control which data certain users have access to. It isn't simply on or off. Autonomous REST Connector saves you and your customers the time and the resources necessary to build and maintain custom one-off connectors. So if we look at the original diagram that we looked at a few moments ago, but we slot in Autonomous REST Connector, you'll see that enterprises are now modernizing how they are allowing their customers, either internally or externally, to access and leverage that data. This new approach is to expose data as a service as opposed to allowing applications or users to go directly back to the data source. This is being done to standardize how data is accessed from a governance perspective, but it also allows for a standard way to consume data using API calls. Take, for example, an enterprise that stores customer data in an Oracle database. Instead of allowing each application to issue a SQL query to the customer tables, they may choose to implement a REST API for requesting a list of customers. What this means is that traditional reporting, BI, and ETL tools that depend on SQL access can no longer retrieve the customer data, and that's where Autonomous REST Connector fills that gap. Autonomous REST Connector allows the conversion between SQL and REST, so there is no loss of functionality when enterprises and applications modernize to leverage the use of REST APIs. There are many benefits to this new approach, and I just want to highlight a few key ones here. First, and this really can't be overstated, you connect your API to any ODBC, JDBC tool. This opens up a vast world of possibilities for empowering your customers. Second, zero code necessary. We made it codeless to expedite the data connection process to make your developers as productive as possible. The data connection is made in a matter of minutes and frees up your developers to work on other mission-critical projects. This is the essence of high productivity. Finally, building seamless connectivity is essential to real-time data analysis. Autonomous REST Connector does not only offer fast and easy API connection, but it also empowers users to query API data as seamlessly as though it were through a native application. But really, enough with the marketing slides. I do want to turn it over to Ken so that he can walk you through a live demo of how Autonomous REST Connector works in action. So Ken, at this point, take it away.
Thank you, James. As you all may be already aware from your customer requests, the ability to effectively work with REST APIs is becoming more and more critical. REST APIs are becoming a key construct for microservice architectures, data sharing, and to provide content across web and mobile applications. But JSON data, whether it's simple or complex, can be difficult to work with, and generally will require some type of coding in order to easily consume it using SQL-based tools. And so your customers or consumers have a few methods to work with JSON today. They could code a solution using Python or any other modern-day language and convert it to a format that can be used and consumed with ease. Or they can make use of a web connector SDK and code a solution that may only fit for a single REST API. Or they may want to go back to direct database access, which allowed them to fully use their SQL toolbox, but IT wouldn't necessarily like that. And all of these options that are available today require some form of coding, maintenance, time, and are often considered point solutions. So I'll be going through a few REST APIs today to kind of just highlight a few of the core features of our new autonomous REST connector. The first one I'd like to show you is just a very classic use case and very familiar with most of you on the phone call today is working with REST APIs using open access. And so I have my Postman application up, just allows me to do simple get and post requests to different APIs that I have access to. And the first one actually is a JSDO. This document essentially describes the metadata and all the services that are available to me as a consumer on my OpenEdge database. And you can see here the name of the service is the sports service. This is essentially the default database that many are aware of that comes with open access, OpenEdge. And so you can see here we have our first service here is called customer. It has some column names, customer name, country name, address, and so on. And so if I'm a consumer of this information, I used to have access directly to the database, how can I start to analyze and use the REST API using my SQL toolbox? And so what the autonomous REST connector is actually able to do is it can connect directly to that JSDO. It can automatically sample the information and parse that out. And what actually comes out of that is this schema information. So from that, we have all these different tables that we were able to parse and extract from that JSON document. And with that, we can actually do some very interesting things. First use case I'd like to highlight is data masking. So if I just perform a simple SQL query to get some of my customer information, my use case here is I may want to expose customer information to both internal and external consumers. To my internal consumers, I may not necessarily need to mask that data because we already have access to this data. But if I'm exposing it to some of my external consumers or third-party suppliers, I may want to mask that data. And so the great thing about using the autonomous REST connector in conjunction with OpenEdge is the fact that it can take advantage of any ABL code you've written on the application layer. And so if I perform the same SQL query and there was ABL code that was used to mask the data on the fly, you can see that if I provided this REST API to my consumers external to my organization, the data automatically gets masked. So there's a big advantage here in being able to provide SQL tooling and bridging that gap to REST API use. And so the other side is reporting. There may be organizations that could have hundreds or even thousands of BI reports that are actively running on your data. If we take a look at a single item, so what we're doing here is we're taking a look at item number 54 from our order lines table. And remember, all this data is coming back in JSON format. If I go back to Postman and just take a look at what gets returned from my order lines API, you'll see a whole bunch of key value pairs that essentially are all of my orders, all the items that have been shipped with each of my orders. And the format of this isn't necessarily very complex, but if I'm a business analyst or I'm a BI developer, I don't necessarily know how to analyze this data. So I kind of have to look at it row by row, key value pair by key value pair. And so just to very briefly show you that we're actually able to write SQL that gets converted to the API that is connected to, and we're able to automatically parse and extract that information into a relational format. So right now, these are all of my order lines that are associated with item number 54, which is essentially just a canoe. And I want to be able to find out what the average discount is. So if I take a look at item 54 and calculate the average discount, it comes to 15.89. So if I already have a set of reports, let's say I have 100 reports for a bunch of different financial analysts, and they're trying to find out which items have the highest discount that's being offered by our sales associates. And if I'm going through this modernization effort, I want to make sure that those BI reports don't have any downtime so that we can continue to run our business. But you need to be able to bridge that gap between the reporting tools that use SQL and the modernization effort you're going through on the back end, where you're converting direct database access to REST API access. So if we have a BI tool that's actually generating the SQL, what I'm doing is I'm performing a join. And I'm performing a join across 2 different REST API endpoints. That's the very specific piece of news here, is that I'm going against my items REST API, and I'm doing a join against my order lines API. I'm able to aggregate that data and determine which of my items have the highest discount. So let's just perform this join. And you'll see my top 5, fins, leotards, ski gloves, surfboard, and croquet mallets, have my highest discount. So I went through thousands of different order lines and items, and I was able to aggregate that value out. So if I had a report, I would be able to seamlessly continue to run my business as I go through this modernization effort. Very, very cool. So I have a couple more APIs, and I just want to show you how we kind of build up the process and look at some of these key features. So the second one I want to show you is a public API from the USGS. It's the United States Geological Survey. What we do here is, James mentioned this intelligent sampling that we have within the Autonomous REST connector. And so as we perform just a big select star from the features table, we get back about 2,000 records because this API has a limit associated with it. We do support paging, but I'm just pulling back the first page of data right now. And so if we take a look at what we were able to create using the intelligent sampling, and so if we take a look at this features table, if we go to this and just run it here, you can see the JSON here, we're starting to get a little bit more of a nested and complex hierarchy of data. And it's a little bit difficult to understand. And one of the more difficult aspects of working with SQL when going against JSON is the fact that everything is inherently a string. There's no real data types, it's just strings. So you kind of have to infer, if you're a BI developer or an application developer, what data type I should be working with. So if we go back to the results of the Autonomous REST connector and look at the schema information, the Autonomous REST connector was actually able to extract column names, data types, and relationships within that nested JSON structure. So you can see we have varchars. We're able to determine, doing our sampling techniques, how long each varchar field should be. We have doubles, integers, and so on. So we essentially take out the guesswork for a lot of your consumers of the data and help them with the sampling technique. And so the great thing here is that I can perform a fairly simple join. This returns 10 records. It's returning the number of earthquakes that happened in the month of December that gave out some type of warning. There is going to be the possibility of having human or financial loss. And so let me show you how easy this actually is to set up. So if you're a consumer of the Autonomous REST connector, this is all you have to do. So let me go to my connections and create a new connection. I've already set up a JDBC connection for the Autonomous REST connector, and the only thing you really have to supply is the driver class and a location to the jar file. So I'm going to click next and supply this new JDBC URL, and I'll hit finish. If I open up a new SQL editor, I'm going to copy and paste the same SQL that I used for my December endpoint. Now I'm going to go against that endpoint I just created. So look at that. In a matter of 30 seconds, I was able to create essentially what would be considered to be a new REST API driver on the fly using a different endpoint. And I was able to use SQL to return data against the results of that endpoint and look at the results in a tabular or relational format. So super easy, super cool. Now, not every endpoint is as simple as the USGS endpoint. If we take a look at one more API from SpaceX, just to show you what we're working with. SpaceX is a publicly available API, and it returns information about launches, customers, the rockets, the ships, the cores, the payloads, everything you wanted to know about essentially the history of SpaceX gets returned in this API. If we take a look at just a single record that gets returned in this JSON document, it's about 119 lines long. About 80 records get returned, so you've got hundreds and hundreds of lines. And as we take a look at the results of this API, you can see that there is a lot of hierarchical data and nested structures. And so how would you be able to work with this? There are some tools on the market today, some are free, some are paid for, that can actually convert JSON to a format that can be used with SQL. But one of the biggest issues with that is that it flattens out the data. Your consumers and your analysts aren't used to working with flattened data like this. They want relational data. And so as that JSON document gets converted, all this information here is essentially the relationships that were not able to be identified during the parsing and extraction process. So I can't work with this if I'm trying to use SQL because I've lost all the relational data that's available to me. So let's take a look at what the Autonomous REST Connector was able to do. If we open up our SpaceX launches, you can see how many tables were actually created. 8 different tables we were able to automatically identify using our intelligent sampling to extract that relational data. Now this tool is pretty cool because I can actually show you an entity relationship diagram. And so just to make it a little bit more visual, you can see from that single API call, we were able to extract and also dynamically generate parent and foreign key, primary and foreign key relationships across 8 different tables. And just looking at this one, just for a quick example, the launches table is basically our main parent table, and all these are various subtables, our children tables, images, payloads, customers, and ships. You can see that there's a relationship between customers and payloads here using these primary keys. Now, just go a little bit deeper. There are no primary keys in this data. And a lot of REST APIs necessarily wouldn't have that either. The only primary key really available would be considered to be flight number in the launches table. So what the Autonomous REST Connector is able to do is dynamically generate these based upon what we're able to discover within the data that gets returned from the API. So to perform that join using that identified relationship, we can see that we are able to find the top SpaceX customers across the payloads and the customer table. And we're aggregating that data based upon payload mass. So we're able to see who are SpaceX's top customers according to payload mass, because I assume that they're probably charging based upon mass of the payload that goes up into space. So just very simple technique, very easy to use, simple to submit SQL. We fully support select statements on SQL 92. So you can do joins, you can aggregate data, you can order by, etc. And so one more example here is Yelp. And the reason why I wanted to show you Yelp is 2 situations, is that it uses a different form of authentication. We were using very basic authentication in the previous examples, and we were really only sampling a single API at a time. And in the real world, that's not necessarily what our customers or your customers would do either. So if we take a look at Yelp, we're going to be going against the categories API, the businesses API, and the events API. And so as you saw me, how fast I was able to configure the USGS new driver within about 30 seconds, I can do the same thing. So if I'm working with 3 to 100 different APIs, we actually can use an configuration file as input into our Autonomous REST Connector. And it's just a very simple format of key value pairs, table name, and the associated REST API that I want to go with. So in this instance, I'm going to be intelligently sampling categories, events, and businesses. And so that happens automatically in the background. When I open this up, you'll see that we have various table names. And so you'll see that some tables seem to be duplicated or redundant, but we automatically are able to identify collisions like that and modify what gets generated on the fly as output for table names. There is a low-code approach to this. You can go into the configuration file and change column names. You're able to change the generated data types along with table names as well. So if something like this happens, if you want to change categories 1 to categories_business, you have full control to do that with our product as well. One great thing about the Autonomous REST connector is the fact that it allows the push down of filters to the API itself. In the real world, most APIs support some type of parameterization so that there's some generic form of implementation, because you don't always want to get the same data back. You want to parameterize it. And there's always some form of paging generally, because you want to be able to control the volume of data that gets consumed by your end users. And so in the SQL world, when we look at parameterization, really we're looking at adding the addition of a where clause. How do I filter out the data that's important to me? So if I run this SQL query, the only thing I'm changing is this business location column, and I'm setting it to La Crosse, Wisconsin. So you can see I was getting all the lawyers from Cary, North Carolina, and now with the change of one where clause, I'm getting all of the lawyers from La Crosse, Wisconsin. So super awesome examples. Just really wanted to highlight how easy it is to set up, the benefits of our intelligent sampling techniques to really dynamically generate metadata information about that REST API and also the relational information about that API as well too. So James, with that, I think I'm going to send it over to you, and we have some time for some questions and answers too. Thank you.
All right, thank you, Ken. That was fantastic. So what's the bottom line? I like to use the analogy of a factory. Autonomous REST Connector is a factory. It allows you to rapidly build data connectors between your API data and your customers' BI and analytics tools. No two connections are going to be the same, and so no two connectors can be either. Autonomous REST Connector is not a universal driver or a universal connector, and it doesn't create a one-size-fits-all connection for REST APIs. Instead, it quickly and codelessly builds enterprise-grade connections to the OpenEdge applications data that your customers need. So with that, I'd like to open it up to questions from the listeners. Please feel free to type in questions that you have about Autonomous REST Connector or about any of the topics that we talked about today. And as you do, I'll leave you with these 4 key takeaways about the product. 1, Autonomous REST Connector is fast. It can be set up and configured in just about a minute. I think Ken did a really good job of explaining that and illustrating that in his demo. 2, Autonomous REST Connector is codeless. It requires no coding to establish a live, powerful connection between your OpenEdge application and your customer's BI analytics tools. 3, Autonomous REST Connector is intelligent. Using our intelligent sampling, the product can infer the right configuration for the API connection. 4th, Autonomous REST Connector is customizable. It offers abundant opportunities to customize how APIs are configured. So you're always able to connect with the data in the way that makes sense for you and for your customers. Now, Ken, I've got a few questions if you're up for it.
Sure, fire away.
All right, Ken, I'm going to go ahead and ask a couple of these questions. The first question is going to be, what are the basic requirements to use Autonomous REST Connector?
Yeah, great question. So one of the basic tenets that we kind of follow, and REST APIs, right? APIs in general are kind of like the wild, wild west of the web right now. There's no real standard as to how they can be implemented, but there are some guiding principles. Right now, APIs, we support JSON responses. We do not support XML responses. Main reason being is that JSON is much more heavily favored as a return type than XML at this point in time, just due to the amount of data that you save. We do support RESTful APIs. We have very limited support right now for OData and JSDO. Those are currently actively in development. But as I showed you in the demo today, we do support some capacity to support JSDO and OData as well. We support parameterized APIs where the parameters can be in the URL or the body. And we can retrieve data and intelligently sample data using either GET, HTTP GET, or POST. And we do support paging as well too.
All right, great. And another question, can intelligent sampling handle very large JSON documents that represent, say, over 100,000 rows of data?
Yeah, great question. So the question is mainly a performance question. And from our product's point of view, there's really two aspects to performance. There's the delivery of the API and the service provider side, which would be OpenEdge. And there's also performance on our side. So as the autonomous REST connector is able to could sample return results that essentially represent a document that has 100,000 or a million rows. It may take some time, but ultimately the performance of that type of throughput is the responsibility on the service provider's side of things. So we can support that, certainly not an issue. We do have some performance capabilities and optimizations like multi-threading, things like that too, that can help.
Fantastic. Third question. You talked a little bit about select statements. Can you only perform select queries using this driver?
Our first release just went GA about a month ago. So from a first release point of view and based upon some customer market information that we had, we only needed to support select for our first release. We will, on our product roadmap, support other various forms of updates, deletes, and inserts as well too. So that is definitely on the roadmap, but right now only select statements.
And final question. What can be customized about this API? You talked about the customization. Once API has been sampled, what can be customized?
Yeah, so it's definitely a difficult task to show all of the features in a short webinar. But when James speaks about low code or no code, we do offer a way to customize a lot of aspects of the results that get generated during the sampling process. You can change column names, you can modify table names, modify data types. So if 8 tables get generated from the intelligent sampling process, you as a data provider could remove 3 of those 8 tables by simply editing a configuration file. So super easy to modify, very easy to get it set up.
Okay, great. That's all the time that we have for today. If you submitted any other questions and we didn't get a chance to answer them, then we will respond to you after the webinar. As always, you can reach out to us at any time at www.progress.com, and I've placed a link on the screen to learn more about the Autonomous REST Connector product. On behalf of all of us here at Progress, I'd like to say thank you for attending today's presentation and have a great day.